This is a slide we've seen before, but again, these were the four main threats that affect invertebrate abundance and diversity. And again, if we look at management practices, which ones are contributing or part of these threats and which ones are counteracting these threats. Here I'll be able to take a little more time on this nice diagram of the 4 soil health principles. So the right-hand side is really focused on protecting the soil by minimizing disturbance. So reduced tillage or no-till is part of that. Maximizing soil cover, that can be relay cropping or cover cropping. So not having fields that are bare over the winter. And then the left-hand side is really about maximizing the continuous living roots, feeding the life in soil by maximizing continuous living roots and maximizing biodiversity. There's one piece here that I think bears mentioning. It's also important that you don't do other things that kill organisms, such as applying pesticides. So in a way that's implied, by maximizing biodiversity, but I wanted to specifically mention that as well. So we look at some effects of tillage or fertilizer or pesticides and how those can be damaging. Of course, tillage is going to lead to desiccation. It breaks the fungal hyphae, destroys tunnels of these soil invertebrates, and it also destroys other burrows or nest sites. Synthetic fertilizer causes all kinds of spikes in nutrient availability, and then certain organisms are going to spike with that and then kind of fall. So you have this boom and bust cycle instead of a more stable, balanced system. And also any excess amounts are lost to the water or atmosphere. So they're causing kind of other harmful effects downstream. And it's also money that's not being spent, that's not really getting into the crops or the field. And then pesticides, they lead to both the direct and indirect negative effects on these soil ecological communities. Just in the interest of time, I'm not going to spend as much time talking about this slide, but this is a recent study that compares the non-target organisms that are being impacted by pesticide toxicity over the past 25 years. So the target organisms are these typically invertebrate pests. Non-targets are the vertebrates, shown here as fish, mammals, and birds, and the non-target invertebrates were grouped into the aquatic ones, pollinators, and then terrestrial arthropods. And these trend lines are just showing how much these different groups are exposed to chemicals that are toxic to them, to pesticides that are toxic to them. And because the type of chemistry that's been used in pesticides has changed over this 25-year period, you can see that's been good actually in terms of its toxicity for these vertebrate groups. Those trend lines are decreasing. But on the right-hand side, for all of our invertebrate groups, they're being more impacted. In many cases with pollinators, the toxicity has doubled in that time period. And this is in large part due to the use or the transfer of away from organophosphates and carbamates and into the pyrethroid and neonicotinoid chemistries. This is the image from our publication, How Neonicotinoids Can Kill Bees, that just shows all the different ways that pesticides can move throughout the environment away from the targeted area where they were meant to be applied. And then for the most parts with these different management practices that we can make choices about, there's one side of them which is helping to support more soil life, such as less tillage, less synthetic fertilizers, less or no pesticides, and higher above ground diversity. And then on the right-hand side of this table, these practices are going to lead to less soil life, kind of the opposite of those. And with that, I will wrap up this section and get started on Module 6 with Kelly.